All right, it is my pleasure to introduce Brent Bobsein. He has come to us from Pittsburgh via State College. So his sense of direction isn't all that great, but he made it here and he made it on time. So we're happy about that. And by way of introduction, I just met him an hour ago, so I can't, usually I like to tell you a little story about, I've known him for years. We just met a couple, all I can say is that he's from Buffalo, so this weather ain't nothing. Like, this, like,
Oh, yeah.
It's fine. So it's like springtime. I know what you guys complain about. So here we go, Brent, and let me change our camera and
Appreciate it.
I think you're ready to go.
Hi, everybody. I'm Brent Bobsein. Thanks for having me today. This is really cool. I'm hopeful to share some things that I've been learning about and working on. I'm an engineer, and I hope you don't hold that against me. I do love working with geologists, though. I have worked with geologists in the past, and I can tell I turned a lot of people off already. You can throw eggs at me as I'm walking out, but no, I think geology is the fundamental driving force behind a lot of what I do. And I had the opportunity to present back at another conference, and somebody from your group pulled me aside and asked me to present, and so here I am. I would love to keep this informal, and if you have any questions or if you want to make comments throughout my presentation, please feel free to stop me, and I'll just pause and address it. I love having collaborative discussions. I think that's how people learn best. So I am going to talk today about capturing coal mine methane from legacy mines in Pennsylvania, and what we can do to use what is today a pollution problem and then convert it into some sort of solution for our domestic energy needs. So how many people here are familiar with coal mine methane or have heard of it in the past? Maybe a few of you. Yeah. Okay. So I won't delve into too much fundamentals, but I do have a really, I'm a visual learner, and I have a visual aid that a team of us put together to try to explain why methane is a part of the mining process, and why degasification is so important from a safety perspective when mining is happening. So what I've got is a YouTube video, and I'd be happy to share this link with anybody if you like the video. And we're starting with kind of an isometric view of what's happening underground. So on the right, you've got unmined coal, and this is typically a longwall mining operation where the blue kind of supports that you see there are roof supports where people are going to be standing underneath that. And that basically is what keeps them from having anything collapse over their heads. And as we click play, if I can figure out, oh yeah, there we go, okay. We'll zoom into what's happening under those blue roofs. So at the front, on the right here is the face, the longwall face, the shears. So this is what's effectively mining this unmined coal to the right, turning it into smaller chunks and bits, and it gets spit out the kind of behind this guy. And that is basically how mining is happening. And so what we're going to see in yellow here is we're trying to animate the methane being released. So within the coal itself, there's a certain gas content. Geologically, each coal seam has a different gas content. And that is going to determine how much methane is kind of escaping into the underground workings. That's one component that contributes to the coal mine methane. The other component, and you can see that yellow stuff kind of coming out as he's moving forward. So as that mine progresses and chews into that coal seam, you saw that roof bolt kind of, or that roof above the guy kind of hydraulic lift. It just pushes up and follows him forward. And as it moves forward, the overlying strata that was previously mined collapses behind that roof support. And what's happening here is this overlying strata could be shale deposits, could be coal deposits, and all of that stuff collapses, fractures. There's mechanical fracturing, there's elastic deformation, inelastic deformation. All of these kind of stresses and strains are causing a release of gas from that overlying strata. And what we're trying to animate here in yellow is as the collapse happens and that mechanical fracturing and breaking of rock and shale and coal is happening from overhead, that is also releasing methane. And that can also get into this working area where this gentleman is mining. So as each kind of roof support moves, we're now going to animate what's going to happen with each thing happening in individual sequence. The width of a mine can be, a longwall operation can be, 500 feet to 750 feet, and the length of an operation can be 10,000 feet long in one direction before they move over to the left or to the right. So going back to this situation here. So this guy underground has got methane coming at him from multiple places, right? It's coming from the coal seam as that coal is being chewed up and turned into smaller bits. That's releasing methane. As this overlying strata fractures and crumbles and unlocks plastic deformation and inelastic deformation from above, that's causing a release of methane. Also, one of the interesting things that actually happens, and I didn't animate it here, is there is, because of this pressure release that happens as you remove this coal and there's less pressure that comes down from above, there's actually some of the underlying strata can also release methane because it used to be held in place with pressure, and that pressure suddenly gets released. So he's got methane coming at him from all sides, right? It's coming from the front, top, back, behind him, below him. So degasifying this mine is what allows this to happen safely. Methane is extremely combustible. Natural gas is primarily composed of methane. Lower explosive limit is 5%, 5 to 15% methane concentration is your typical. Go ahead.
9.
Yeah.
9 is the back one.
Yeah, and so they don't, down underground, they don't want their methane concentration. I think MSHA, so Mine Safety Health Administration, regulates the methane concentrations underground, and they must be below 2% at certain mines. If that methane concentration in these concentrations where these miners are working are monitored with high frequency 24/7 at multiple locations. If that methane percentage gets to 2%, they have to evacuate the mine, right? It's a bad day for everybody out, and we have to wait until the methane concentration comes down. So mine operators don't ever want this methane concentration to get to 2% because of operational issues, but that Mining Safety Health Administration set that limit for a reason, and that is because underground explosions are the #1 cause of disasters in the mining industry, right? And so looking back to, the 1800s, you had the canary in the coal mine, which was going out and looking for methane, and if that was a problem, the canary died, they had to get out, right? So this is now being monitored with devices underground, and there are now procedures and processes in place that we'll go over next to get this methane down at safe limits to avoid any potential explosions or health hazards and safe operation of the mine. So how do mines safely degasify the mine? And so we saw the crumble there. What typically happens, traditional mine ventilation, they'll have an air intake above ground, which effectively they they pump and they sweep across this working area with fresh air, and they push the methane out a vent stack. So if you are a miner working underground and you're standing here at the longwall face, you can actually feel the wind. It feels like you're standing in a storm, because you can feel the wind being pushed by these big, massive fans, and your pants and your sleeves are blowing in the direction of the airflow. The problem with this methodology is, look, there's methane going to atmosphere, right? This methane going to atmosphere is of a concentration, like we said, it's less than 2% methane, and is mainly nitrogen, atmospheric components, CO2, oxygen, right? So it is very difficult to do anything with this methane, and as you are all probably aware, methane is a very potent greenhouse gas with a global warming potential that is roughly 28 times that of CO2, meaning for every molecule of methane, or every ton of methane, rather, that's vented to atmosphere, it's over 100 years going to do 28 times more radiative forcing and trapping heat than CO2. So it's potent, and it's even more potent than that, like 80 times as bad over the next 20 years. So from a global climate policy perspective, mitigating methane pollution has been kind of one of the highest priorities amongst the United Nations in different policies. So what makes it difficult to kind of capture this stuff and do something useful with it is it's very dilute. At 2%, it's not combustible, right? And inherently isn't combustible because we don't want it to be combustible, so it doesn't combust underground. But the fact that it's not combustible at 2% concentration means, unlike with oil and gas operations, you can't flare it, right? This 2% methane concentration won't flare. And so they have these massive pieces of equipment that they try to install called regenerative thermal oxidizers that effectively raise the temperature in a enclosure up to around 400 degrees. And at that temperature, at this concentration, the methane combusts. That's very expensive, and it's basically just destroying what is a potential energy source for the purposes of avoiding a greenhouse gas emission, but then you create CO2, right? So what else can we do to avoid this pollution while maybe doing something useful with it? So what I'm going to show you next is another degasification procedure. What we talked about was, and these are called degasification boreholes. So if you noticed previously, we talked about this overlying strata that had collapsed over here to the left, and how that was contributing to the methane concentrations underground. So let's back up here before I poke those holes in. You see the direction of these arrows, basically, of the that shows which direction the methane, the yellow lines are the methane, which direction they're moving in. They're moving from that collapsed overlying strata, which the mining industry refers to it as GOB, G-O-B. That is one of the main sources of the methane that they're trying to get to their exhaust. Well, another way to deal with this and degasify this mine is to go straight to the source. So do you see what happened there with the direction of these arrows? So these methane molecules are no longer making it into this ventilation system, and it's not getting to these miners because it's being piped straight to the surface. So for example, in coal mines in Greene County, Pennsylvania, the depth of coal is roughly 750 feet. The coal thickness, somewhere between 6 and 8 feet thick. So we are today drilling down these, we call them GOB ventilation boreholes, into the strata that we anticipate to collapse. And we're trying to pull that methane out at the source before it gets to the mining operation. And if we do that, the concentration of that methane is significantly higher. And with that significantly higher methane concentration, we can then capture it at that point and do something useful with it. So we have pipelines, compressors, processing facilities. This methane concentration at these sources can vary from 40% all the way up to 90 some odd percent methane. So with that higher concentration methane, we can do all sorts of things. We can convert it into electricity, we can make heat, or turn it into some, synthetic fuel of the future that our company is looking at, like sustainable aviation fuel or hydrogen. So that's the general premise of our process. This is something that we do today. I wanted to highlight the difference between coal mine methane and coal bed methane. So what we talked about was coal mine methane. Now, coal bed methane is just an oil and gas resource that is completely separate from a mining operation, but it's a well that taps into the actual coal strata itself and tries to extract the methane from that coal strata. So it's not the fractures that feed into a coal bed methane well are not caused by a mining operation, whereas coal mine methane is directly related to that degasification. Any questions on that? I know that's a lot of information. Maybe some of you are already familiar with it, but okay.
Operating in Greene County?
So there are active underground mine operations in Greene and Washington County, Pennsylvania. And CNX does have operations.
That would be the Pittsburgh scene.
Yes. Yes, sir.
Tom?
Just a general comment.
Yeah.
So these mines are well below water table, so a lot of that pressure that's been removed is from the water that's been removed in order to mine the coal.
So what we've noticed about the Pennsylvania mines is that there is not a lot of water produced in the GOB ventilation boreholes, but there is certainly a dewatering that's happening underground in a water management system that each mine handles their water and processes their water in a different way. So yeah, water is definitely a big part of this. Now, one thing that we'll talk about is what happens after active mining is done. So a mine gets sealed effectively so that the water doesn't drain. We have like the legacy mines may have like acid mine water issues, but Pennsylvania, as you are all probably aware, has very specific procedures for sealing mines so that doesn't happen in the future. But these mines will still vent methane to atmosphere well after they've become sealed and abandoned. And today, legacy methane emissions from abandoned mines are still, decades later after they've been abandoned, it still continues to emit methane to atmosphere today. Now, water does, in some cases, these abandoned mines will fill up with water and kind of, I've seen the water level kind of rise within a given mine area. So at lower elevations, the methane production will drop off, and then at the higher, like the highest kind of corner of the sealed district, it will kind of still be producing. So it's kind of bubbling out of the water and then moving into the kind of highest point. Yeah, so that was a good point. So how do I get to the power plant? Let's see.
So typical mines usually use vacuum to de-vaporize a mine from methane. You're using pressure to do it?
Vacuum of at the GOB ventilation boreholes will, yes. So we will pull a vacuum on a GOB ventilation borehole.
Okay. I mean
Ventilation.
for ventilation in space, they usually vacuum an air
Yes,
shaft.
that's right. That visual I made was an attempt to recreate a vacuum, which is basically what the vent shaft, what it's doing is it's moving air across the face and sucking air across, yeah. So what I was going to talk about today is how we can use this today, which is potentially a polluting consequence of a legacy industry here in Pennsylvania, and turn it into a valuable resource. So again, this is for safety issues, right? Like this is degasifying a mine at its core is to keep underground workers safe. The International Energy Agency does put a volume on it of around 40 million metric tons of methane in the atmosphere in 2022. That's 10% globally of methane emissions, which is, so the size of the prize here is pretty large. This is a little bit kind of zooming out and putting it into the context of the mine. So another visual here. So let's see, air intake here, moving across where the underground mine workings are, coal faces here. As that coal is mined, the overlying strata collapses and turns into that gob. That's where a lot of the methane comes from, and we're pulling that to the surface. That air now, as it goes across that face, picks up the methane, and it returns to this ventilation air methane bleeder fan, and then is more dispersed, less than 2%, as it's vented to atmosphere here. So unfortunately, this problem and this pollution issue is forecasted to get worse with time, not better. We traditionally think of coal as a kind of a legacy industry that's decreasing in its utilization, but globally, coal mining is still kind of status quo in terms of total production. So while coal mining has decreased here in the U.S. and in Pennsylvania, it is certainly increasing. The amount of mining activity is increasing in China and India, which is even more gassier in some instances in China. So when you look at the reserves on like what's left to be mined in China, with it being gassier, with the overlying strata being gassier than it is here, the actual pollution in terms of methane that is anticipated to go to the atmosphere in the future is even higher than it is today. So the blue kind of shape here is active mining, and the green shape is abandoned mine methane estimates, kind of going out across the horizontal axis is a forecast into time. And so both active and abandoned emissions are forecasted to get worse with time. So this problem left unaddressed won't solve itself. So how about in the U.S.? And so from a geologic perspective, I thought this might be interesting to you. So where is this coming from in the U.S.? Each orange dot represents the volume or concentration of methane that's currently being liberated at various mines within the United States. And you can see the Appalachian Basin between southwestern Pennsylvania, northern West Virginia, and then Virginia. It's kind of the epicenter. And that same geology kind of goes down to Alabama. And the underground longwall mines in Alabama are certainly very gassy as well. So geologically, there's a lot of similarities between all of these mines, as you all know. They're historically pretty similar. This is kind of the largest concentration. Also, there's some active mines out in Indiana, Illinois, Colorado, Utah, New Mexico that have lower concentrations of methane. So this data comes from the EPA Greenhouse Gas Reporting Program. What is not shown on this map are abandoned mines or above ground mines. Neither abandoned mines or above ground mines are obligated to report their emissions to the EPA. So nobody really knows how much methane is coming from abandoned or surface mines today. but we know that it certainly is, because if that coal is being mined from a surface mine, it is inherently releasing the methane. Current estimates of emissions in the US. So I mentioned the greenhouse gas reporting program. So this is what people are reporting, 30 million metric tons on a carbon dioxide equivalent per year. When you add in the abandoned mines and estimate some of the missing pieces, EPA estimates around 50 million metric tons. Global Energy Monitor, which is a independent European organization, when they go and they look at the US and they look at satellite data and they look at kind of the concentration of methane geologically, they estimate it to be more like 80 million metric tons, which is being emitted to the atmosphere every year. So it's difficult to put a pin on exactly how much is being emitted. Unfortunately, there is not a lot of capture happening. So there are 539 active mines in the US. Only 13 of them are capturing coal mine methane and destroying it, converting it into CO2, while the overwhelming majority are venting to atmosphere. Very similar story on abandoned mines. So how can we change that? How can we use this stuff? Well, I showed you a little bit about our process. This is another kind of visualization of it. So we do, for mine safety purposes, need to install a lot of compression horsepower to get the ventilation to a point where it's pulling on the underground working. So we do pull a vacuum on those gob ventilation boreholes. It is very expensive. A lot of horsepower deployed in our operation in order to get that pressure down. A lot of pipelines moving that gas from compression to processing at an aggregation point. Because we're pulling on atmospheric components, we have a lot of nitrogen, carbon dioxide, and oxygen. We can't put that into end-use applications because those systems aren't built to handle the nitrogen and carbon dioxide, and so we have to process and remove them before we transport it to an interstate network, which then goes into a residential system. So just looking at the United States, if you look at total capture outside of CNX's operations in Virginia, they are only getting around 14% captured in terms of volume, but we are able to get 86% roughly on average in our system. There is a large pivot, there's been a large pivot historically from beneficial use towards flaring, and there's a history behind this. So, you know, pre-2007 shale revolution, natural gas prices were very high, $9 per MMBTU. There were federal subsidies for alternative energy tax credits that drove a lot of investment into capturing this coal mine methane for beneficial use. So on the far left, we see the number of capture for beneficial use projects in the US. It was around 15. That was around 2010. Now flash forward to 2022, and we see this darker green bar chart on the right, and we only had 5 active mines with capture for beneficial use operation. And that has gone down to 4 as of last year. So it's decreasing. The reason it's decreasing is natural gas prices went down, that federal tax credit expired, operating expenses, electricity, inflation, right? Expenses going up, revenues going down. Even with existing systems, they had to decommission them. They couldn't maintain their operating expense. Meanwhile, with the advent of carbon credit markets, certain carbon credit markets, voluntary or compliance in the California Air Resource Board. So California is a state that, in Quebec actually, they will effectively pay somebody to go put a flare on these gob ventilation boreholes, and they will pay you a certain dollar per ton of methane that you convert into CO2. And so we've seen a big increase in the number of flares that are being deployed. But the downside to me of flaring is you're destroying the methane and you're lowering the greenhouse gas impact, but you're not really coming up with a permanent solution. These flares are temporary. They're not sized to fit the declining nature of the source. And it's also a waste of energy, right? If we have this domestic energy need and globally our energy requirements are rising, not falling, shouldn't we be doing something useful with this rather than just destroying it? So I wanted to zoom in on Pennsylvania, and I'm going to switch back to this. So in Pennsylvania, if you had to guess, and I'm going to pull up the greenhouse gas report from the state, what would you say, what percentage of industrial emissions come from coal mine methane? In the state of Pennsylvania, industrial emissions, so this is getting grouped in with things like steel making and manufacturing, all industrial emissions. Coal mine methane's a part of it. What percentage would you guess is coming from coal mines?
2%?
2%? That's a pretty good guess. Anybody else? It is around 14%. So what we're going to see here is natural gas and oil. So like leaks in like oil production or natural gas production, and leaks in like the gathering system. That's around 16 million metric tons. Coal mine methane is 11.6, so it's around 14% of the 80 million metric tons. So it is a large part of Pennsylvania's greenhouse gas footprint. Go back to my, wrong way. There we go. Is this, am I doing it right? Does that work? Sorry, I'll let you.
There you go.
So methane in total in Pennsylvania of greenhouse gas emissions, it's around 13%, and within the industrial sector, as we looked at earlier, coal mine methane is around 14%. So now I'll pivot to what we're doing in Virginia and what I am trying to develop in Pennsylvania, and that's collection for beneficial use. So this is a picture of our system. On the far right, you'll see the blue is kind of the area that we capture the methane from, and the black lines are pipes that we've built to connect into different beneficial end uses. And so we actually cross 3 states with our system: West Virginia, Virginia, and Kentucky. We have hundreds of miles of pipe connected to hundreds of wells. The amount of methane that we capture is, on an equivalency basis, around 1 million gasoline vehicles operating for a year. That's how much pollution we're able to avoid by capturing the methane in Virginia. Or, 600,000 homes, which is a very large, city. Their energy use we're effectively offsetting by capturing this methane and doing something beneficial with it. So it's a pretty measurable, tangible, and impactful thing. So we talked about kind of the problem, and what I've been trying to advocate for and get support for is having some sort of marketplace or demand side premium to realize that this is not easy to do, it's expensive, and we need some sort of additional incentive in order to deploy these systems to go capture what is today a pollution problem and turn it into useful energy. So there is no regulatory framework that says this methane must be captured. So while MSHA says you must get it to surface, EPA does not regulate these emissions like it does with oil and gas. We talked about business as usual. It's very rare. These systems are very rare. The amount of methane being captured with flares is de minimis, and so it's very outside the norm and deserving of additional support in order to deploy. So that gets us into carbon markets, and one of the things that I've put a lot of work into over the past 3 years is developing markets and customers that appreciate the environmental benefits of this energy resource, really similar to renewable natural gas. So some of you might be familiar with landfill, dairy, swine farms. They deploy methane capture systems there, and they have end-use customers who pay a premium or are supported with subsidies federally or at a state level for that methane. So we are looking to create something similar to the renewable natural gas policy to be applied to coal mine methane here in Pennsylvania, so that we can deploy new systems to capture and convert this stuff into some sort of beneficial end use. There's a lot of things, requirements that we have to go through in order to be eligible for those types of programs. I've just kind of listed some of the things that we're working on to be transparent with people in the marketplace about what we're doing and why it's environmentally beneficial. One of the more technical and interesting things I thought you might be interested. So NIOSH did a study that they basically, if we go back to the, maybe I'll, sorry. Back to this visual. So NIOSH did a study where they injected chemical tracers down one of these gob ventilation boreholes, and they shut in the borehole here, and they monitored, and they saw that same chemical migrate through this underlying gob strata out and up into this ventilation shaft, meaning they've proven the interconnected nature, which you can see it's interconnected, but they were able to prove with tracer studies that it will migrate from one to the other. And they actually did vice versa, where they injected a chemical tracer behind this shield right here, and they pulled on it, and they got it to come out of this gob ventilation borehole. And that's what this study confirms. And basically, they were able to show after 47 minutes, it moved from one to the other, or in some cases, it was a few hours. We have worked with the Department of Energy and EPA to get some more support for new systems. I'm really hopeful that we'll be a part of Pennsylvania's RISE PA CPRG grants. That's something that we're looking at, as well as some incentives made available through the Inflation Reduction Act. Also in Pennsylvania, the Alternative Energy Portfolio Standard, the electricity portfolio that every electricity producer or retailer has to have a certain amount of alternative energy in their mix. Coal mine methane is a approved product, so when converted to electricity, we can help these suppliers or distribution companies meet their required alternative energy portfolio. So key takeaways that I'll leave you with. While today there's no legal requirement to destroy that methane, it is required to be liberated. It's not very common to use it beneficially, but we're trying to do more. We're trying to get the policy support to do more. And I see over the next 5 years a huge opportunity for Pennsylvania to become a leader in low carbon gas and supplying reliable energy to growing energy demand while also reducing pollution. So that is my, my story. Thank you.
So those of you online, please put questions in the chat. We do have one about radon. How is 222 radon from methane capture wells handled? What is the typical radon concentration for captured methane in Greene County?
Oh, that's a really good question. I actually don't know the answer to that. We haven't, although we haven't tested for it, I would say that it hasn't been something that we've identified as a problem yet. Yeah.
Okay, you operate primarily in long well lines?
Yeah, operating in continuous mining, room and pillar sections, because they don't have the gob formation. We do have some pre-mine drainage wells,
Okay.
which I didn't go through today because it's a little bit of a more complicated degasification procedure, but we do have some pre-mine drainage wells where we take the methane out of the coal seam before the mining gets there. So we do have pre-mine drainage wells in room and pillar mines
Well, as you
around in advance.
As you advance your face in the longwall panel and moving the shields up, when the gob starts falling down, that's the primary production of
Yes.
degassing. So how far behind the shields do you operate with your borehole?
That's a really good question. So the boreholes.
Did he collapse?
Yeah. Yeah. So the boreholes are installed in advance of the longwall.
Okay.
And what we see is, so we usually land about 50 feet above the coal seam that's being mined.
Right.
Some cases we'll have slotted pipe, in some cases we'll go open hole. And we have seen situations with the open hole where the gob collapse pinches off that access, right? But in the case where it pinches off, what we'll see is the gob vent borehole that's behind it goes up. And so we do see these things communicate a lot, where if one goes down, the other kind of goes up and kind of balances. So yes, we do see collapse, but it's all an interconnected system. So if it's not going out one path, it'll take a different path.
Okay, thanks.
Yeah. Yeah, go ahead.
Just out of idle curiosity, is there some percentage of methane in the atmosphere that's too rich to be explosive? It would probably be suffocating,
I
but
think it's in the 30s, but we don't. Yeah, I think it's like 5 to 15, right? Is the range? But like we never from a gas operations perspective, we never pulled down below 30% because we don't want to get close to that explosive limit. So I think 15 is the technical, depending on the temperature and pressure.
It's not enough oxygen at 15.
Yeah.
9% is the worst. You'll get the biggest explosion with that. 15 or above, you don't have enough oxygen, but you don't survive it. You won't survive in this.
Right.
yeah, I mean, it would suffocate you at that
Yes,
level.
exactly.
Yeah. So, but we avoid so you can kind of see the safety buffers that they put in. Like most of these mines operate well below the 2% threshold, which is a buffer to the 5%. But because of the coal fines underground and like those rotors that we were showing at the longwall face, they hit rock, there's sparks, right? So there's definitely impetus for explosion that's happening underground. And the coal fines and the pressures underground also potentially lower the methane explosion percentage from 5% down to something closer to that 3 to 4% level. So they really try to be safe by keeping it well below 2%. And we, on the surface, we don't want to get near the 15%, so we have a safety cutoff at 30.
Something different. I know they're coming up with some new materials now that literally physically capture carbon dioxide.
Yeah.
And that can then be,
Direct air capture.
Yeah,
or
repair and capture, and then it can be released from those materials by heating them slightly.
yes.
Is there anything similar like that in the works with methane?
Yeah, I think there is. There's like some sort of clay thing that they've been researching. So I work for a company called CNX. Like the way that we got into capturing this methane is previously we were a part of Consol Energy, and we split. So Consol's got the mines now, and we've got the gas operations. Consol did a bunch of projects with DOE on a few things like that. One is a catalyst. Instead of a regenerative thermal oxidizer, they've got a catalyst system that lowers the methane concentration. And I know that MIT did a study with clay to absorb methane, and I honestly don't know if that's commercially successful yet.
Probably strictly speaking, adsorb the methane.
Right.
I have a question then. The question of groundwater effects came up back here. What's your economic outlook when you know that once they stop mining out here, the groundwater is going to come up
That's true.
and completely shut off
Some of the wells, yeah. So that's a really good point. So as I was mentioning, like some of the wells we expect to have a longer useful life, and the way that we kind of model it is like in Pennsylvania, for example, 1 every 4 will be plugged in the first year, just due to water or being pinched off. So we just kind of assume that one every 4, we're going to go out, we're going to have a good 6 months, and then we're going to have nothing. So we bake that into the modeling, and then after about 5 years, we'll model another well because of water. Yep.
Do you ever get enough gas to actually come up to pipeline quality?
Yes.
Is that what, 1,000 BTUs per cubic foot?
Yeah, so what we run up to in pipeline quality isn't necessarily the BTU per cubic foot, but the total inerts percentage has to be below, I think, something like 3%. And so, yes, we do though. And yeah, so on an active gob ventilation borehole, we can have 97%.
Really?
Time production. So I mentioned that, let's go back to this. So I mentioned that we space these out, every, call it, in some cases 750 feet, some cases 1,000 feet, something like that. And as this longwall mine approaches, let's say there's another one of these here, you can actually see it go, you can actually see the gas volume rise up as that longwall mine passes underneath that location, that fracturing starts happening. It goes from next to nothing, you could call it like 2 MCF to 7,000 MCF per day. It just like a 1,000-time volume increase over the course of a day, because that mechanical fracturing that's happening underground. Flush period, we can have above 95% methane for 2 months to 6 months.
Is there any effort made to continue to generate methane through like microbial degradation or other enhanced production?
There have been some people out west who have done that. That's not something that I'm focused on, because I see that more of a resource play, right? So we've got coal that we can turn into methane. I think this area is blessed with a lot of natural gas resource, right? And so I'm really focused more on the pollution mitigation aspect, and that environmental attribute carrying through into new capture, whereas I think the microbial process that you're talking about is more of a new resource opportunity. So yes, people I think I've seen a presentation from somebody in Wyoming that has done that.
Yeah.
What's the end use of the gas that you're producing in Virginia?
We transport it to a power generation facility in Pennsylvania to generate the alternative energy credits. And so that is the only reason we're able to continue that operation in Virginia. And it's why it's one of only 4 facilities in the United States that hasn't closed, is because we're able to generate these credits in Pennsylvania. But unfortunately, that credit value is not enough to deploy a new system. It's enough to keep the operation running and kind of keep the doors open in Virginia,
made the investment.
because we've made the capital investment. But on a go-forward basis, that's why I'm working on some of these other pathways, like the climate pollution reduction grants and some of the Inflation Reduction Act opportunities to come to Pennsylvania. One thing I didn't mention is we've also worked with a voluntary buyer, a company called New Light. They are a bioplastics company, and so they actually buy our coal mine methane, and they make plastics out of, basically they have these microbial things that eat the methane in salt water, and they excrete a bioplastic, and they collect all this excretion and they extrude products. So Chipotle, Shake Shack, and Nike use this bioplastic, and they label it zero carbon because they're taking some of our coal mine methane and converting it into plastic. So the next time you're at Chipotle, you can look at your spoon and say, hey, maybe this came from something that was going to go to atmosphere and got captured and turned into a spoon.
But what happens to that? Like,
yeah, so that's it. They showed me a really cool, they took ocean water and they put it in a glass container. They put a spoon in this ocean water, and whatever bacteria or organisms in that ocean water recognize that kind of biologically derived plastic, because it's found in nature, and so it started eating the spoon, and it like turned into like basically if you have it sit there, I think for 2 weeks, they said it'll be gone, which is just incredible.
It becomes
Yeah, it's back into the
bacteria
cycle.
food.
Yeah,
That's cool.
which is really interesting.
This is an excellent presentation here, but I just wondered, have you ever heard of, so you're from Virginia, of course, but have you ever heard of the Pennsylvania Abandoned Mine Reclamation Conference?
I have not, no.
Okay, because a presentation like this would be a perfect addition to it for next year's conference, and I can get you in touch with the person.
Great, yeah, I'd
Person
be
who
happy
actually
to.
manages that particular conference.
Happy to, thank you.
We have a whole bunch of questions online, a lot of them kind of repeating what's been discussed here. So picking out some of them, when a methane capture system, when they're decommissioned, how are the capture wells abandoned?
So if any, that's a good question. So from a DEP perspective, we did have a facility that was in operation in southwestern Pennsylvania that we had to decommission because the operating expense got to the point where we couldn't continue to operate. And so we had to plug those wells, and all of those wells were registered with Pennsylvania DEP as oil and gas wells. And so we had to plug to the oil and gas standards.
And what is done with the waste gases from the separation process?
So yeah, like nitrogen will go to atmosphere. So like, yeah, the nitrogen and so in the oxygen we use in a catalyst to actually combust it, and then the nitrogen just goes to atmosphere from the amine system.
There isn't anything else.
Yeah, we're left with atmospheric components, and then we put the atmospheric components back into the atmosphere.
Let's see. What about storage piles? Based on methane detection images, it is a major contributor.
That's true. Storage piles. I think that there was somebody. So two things. One, above ground mining is not obligated to report to EPA, although theoretically it does emit methane to atmosphere, and they try to estimate in that's happening. And yes, storage piles, and particularly I think with whoever asked this question might know more about it than I do, but yeah, you can have heat basically that in a large pile, you can have heat creation that then causes the coal to release more methane.
That was Jay Parrish asking. I'm good. Anyone else? Any more questions? Yeah, there was a whole bunch of questions, but it seemed to be, you guys are on the same wavelength because there was a lot of duplicate questions going on. So I think we covered everything.
Cool.
Hey, and look at that, we got you signed up for another conference. So
Yeah,
you're just
perfect.
It's just going to
Thank
be
you.
a strict. Bill, did you have something else?
It's more speculative at this point.
Sure. We love
Obviously, a lot of this going forward depends on political
Good point.
point,
Yeah. On the
so forth.
on the
Let's say
climate
the ball is clouded.
Yeah. So what I'd say to that is, I think that this is something that both sides of the political aisle can get behind, because it's both climate impact, reduction, and that's been kind of our focus over the last with the last administration, but it's also domestic reliable energy in coal communities, right? These are some of the hardest impacted communities by the energy transition, and it's frankly, it's a lot of red districts that these jobs would where this economic benefit would be. So I do think that it hangs on. I think that there are certain things that were passed legislatively that that are going to stick around because it is domestic energy, it's jobs, and it's jobs in the right area. That's my hope.
That's the kind of attitude, spirit, whatever, that we get in Pennsylvania. So a lot of the work that we're doing here at the survey with carbon storage and all of those things, right? It has aspects that please all sides of the political.
Great.
Hey, how about, is there any of this technology, this idea that could be applied to landfill
Yes.
outgassing?
Yeah, so landfill, what I'd say about landfills is two things. One, what I'm basically trying to do is replicate what landfills have done. So I think that there are a lot of regulatory requirements today to mitigate methane emissions at landfills, and there's a lot of policies, both federal and state level, to support landfills. Like, for example, the renewable fuel standard, if those of you who aren't familiar with it, it's a federal policy, and there's roughly a $30 per MMBTU premium assigned to landfill gas when used for CNG transportation fuel. Compare that today with typical in-basin Marcellus pricing, because we also have Marcellus wells, I have to know this. We're selling for around $2 per MMBTU, meaning landfill gas gets 15 times the value as a molecule of methane from a Marcellus well. So yes, landfills are absolutely incentivized today, and Waste Management is a leader in taking methane from their landfills and then putting it back into their vehicles. Like all of the garbage vehicles that you see, the majority of them run on CNG actually from the landfills. So I'd like to do that same thing for coal mines.
Well, Brent, this was great. Thank you.
Yeah, thank you.
Well, that concludes 2024. See you guys next year. Don't forget to sign in, and have a happy and safe holiday season. And we'll see you in February.
Great question, sir. Oh, no. Hi, Tom.
Yeah, I recognize you, Jeff.
Yeah.